So now we are going to discuss the 96th question. See the question here. In a CRT, the electrostatic deflection sensitivity and the magnetic deflection sensitivity are proportional dash and dash with the accelerating voltage here respectively. So basically in this question they are saying that in a CRT, what is the electrostatic deflection sensitivity as well as the magnetic deflection sensitivity, the relation with respect to the accelerating voltage we need to figure out. So out of these four options, we can say the electrostatic deflection sensitivity is always directly proportional to 1 by VA, whereas the magnetic deflection sensitivity is always directly proportional to 1 by under root over VA. VA is called as the accelerating voltage. So let's solve this numerical. So option C is the correct solution of this question. So today I have some problem with my noise, so please listen carefully. So we can say electrostatic deflection sensitivity. So you can see clearly here. So this is the deflection plate 1, deflection plate 2. So the distance between these two deflection plates is small d. Small d is the distance between these two plates. So therefore now L is the length of this deflection plates. This is basically fluorescent screen. It is a fluorescent screen. So from the center of this deflection plates, this one, this is the distance from the fluorescent screen to the center of this deflection plates is called as the length L. It is called as the length L. Here for these plates, I am going to supply voltage of VD. VD is called as the deflection voltage. Means I am going to supply some voltage of VD for these plates. So this is basically an electron. So because of the Lorentz force law, it is going to go like this in a straight line, and finally it is going to this fluorescent screen at a distance d from the center of this fluorescent screen. So this is the distance between the electron which is hitting this fluorescent screen with respect to center of this fluorescent screen. So now let me tell you what is the meaning of electrostatic deflection sensitivity. It is the ratio of the distance d by the supply the deflection voltage Vd. So you can say the electrostatic deflection sensitivity is the ratio of the distance d by the Vd. So yes, Vd increases, d also increases. So this ratio we need to do, which is d by Vd. What is the input Vd and what is the output, which is d. So the ratio of the output by input is called as the sensitivity. So output is distance and the input is Vd. So SC is equal to d by Vd. So if you do the ratio, finally you are going to get this concept I have already told in the case of measurements, but I am going to give you the direct formula, which is capital L into small ld by 2 into d into Va. What is L? L is the distance between the fluorescent screen to the center of the deflection plates, where Ld is the length of this deflection plates, where d is the distance between the plates, and Va is called as a accelerating voltage. So therefore you can see the electrostatic deflection sensitivity is equal to L into Ld by 2d Va. So what is the relation with respect to accelerating voltage, which is so Sc is always directly proportional to 1 by Va. So this is the relation between the electrostatic deflection sensitivity as well as the accelerating voltage. So now we will discuss the magnetostatic deflection sensitivity. So magnetostatic deflection sensitivity, now we are going to discuss this one. Same thing here, these are the deflection plates. So L is the length of this deflection plates. So now the L is the distance between the center of this deflection plates to the fluorescent screen. So this is basically the electron. So now I am going to apply the magnetic field. So because of this, the force, because of this magnetic force, it will go like a parabola shape, and finally it is going to hit the fluorescent screen. The distance between the center of this fluorescent screen to the hitted by this electron on the fluorescent screen is called as the distance d. So what is the output here? D. And what is the input here? Magnetic field. So what is the magnetostatic deflection sensitivity? It is a ratio of the output by input. So it is the ratio of the output by input. So output is D and the input is B. So therefore SM is equal to D by B because output is distance D and the input is magnetic field. So then if you solve this one, finally you are going to get L into LD into under root over Q by 2MVA. What is L? L is the distance between the fluorescent stream as well as the center of this deflection plates. L is the length of the deflection plates and Q is the charge of the electron and M is the mass of the electron and VA is the accelerating voltage of this electron. So if you solve this one, finally you are going to get L into LD into under root over Q by under root over 2M into VA. So we can say the magnetostatic deflection constant is always directly proportional to 1 by under root over VA. VA is called as the accelerating voltage. So now let me tell you what are the notations. SA is called as the electrostatic deflection sensitivity. SM is called as the magnetostatic deflection sensitivity. And D is called as the distance, the deflection on the fluorescent screen, or the distance between the electron emitted by the on the fluorescent screen with respect to center of the fluorescent screen. Where L is the distance from the center of the deflection plates to the fluorescent screen, whereas LD is the length of the deflection plates, and VA is called as the accelerating voltage, and VD is called as the potential between the deflection plates, and B is called as the magnetic field. So these are the notations. So finally, I can only say one important thing, which is, so finally, the electrostatic deflection system is always directly proportional to 1 by VA, whereas magnetostatic deflection system is always directly proportional to 1 by under root over VA. So this is what the conclusion. I have given the direct formulas. So I have given the direct formulas only. So option C is the correct solution of this question. So now we are going to solve the 97th question. See the question here. At constant supply voltage, if the supply frequency to the stator varies from the rated frequency to the twice the rated frequency, then in the three-phase induction motor. So in the question they are saying that the supply voltage is constant, but the frequency is increases. It is more than the rated frequency means. So it is more than the rated frequency. It is increased twice the rated frequency means the frequency is more than the rated frequency. So it is increasing. Then what is going to happen in the case of three-phase induction motor? Supply voltage is constant and the frequency is increasing from rated frequency to the twice rated frequency. Then what is going to happen at this condition in the case of three-phase induction motor? We need to figure out. So out of these four options, option D, which is power developed remains constant, is the correct solution of this question. So let's solve this numerical. So this is the three-phase induction motor. This is the diagram between the flux as well as the power. So you can see clearly below the rated frequency. So below the rated frequency, the flux is constant, but above the rated frequency, the flux decreases. Whereas below the rated frequency, the power is a variable, but above the rated frequency, the power is a constant. So in the question, what they are saying is the frequency is above the rated frequency, means it is increasing from rated frequency to the twice the rated frequency, means we are going in this direction. So the frequency is increasing from rated frequency to twice the rated frequency. Then what is the thing? Power is the constant. Power is the constant, but the flux is the variable. So power is the constant. So option D, which is the power is the constant, is the correct solution of this question. But let me discuss here. So whenever the frequency is lesser than the rated frequency, then what is going to happen? Suppose if the V by F ratio is constant, means V by F is nothing but because the flux is always directly proportional to V by F. So if V by F is constant, then flux is constant. As you can see clearly from the picture, whenever the frequency is less than rated frequency, the flux is constant and the power is variable. So power is variable. Suppose for the above the rated frequency, suppose if V by F is not equal to constant, then as I have already told you, flux is directly proportional to V by F. If V by F is not constant, means flux is also not constant, means it is variable. Then, as you can see clearly from the picture, for above the rated frequency, power is always constant. So power is always equal to constant. So now we will see in the for the above the rated frequency, suppose as frequency increases, then as we can see clearly, the fluxes decreases. As you can see clearly from the figure, the flux is decreasing as torque is directly proportional to flux. As flux decreases, torque also decreases. And as if see, ns is directly proportional to frequency. So as frequency increases, ns also increases. As ns increases, nr also increases. Whereas ns minus nr both are increasing, so the difference will decrease. So P is equal to T into omega r. P is the power, T is the torque, and omega r is the speed in the radians of the speed of the rotor in radians per second. So for above the rated frequency, power is constant and torque is reducing. So if this constant means this is decreasing means this should be increased. Then only their power is constant. So omega r is increases means nr increases. So their difference ns minus nr will decrease. It is called as the slip speed. So slip speed. So finally I can say only one important thing, which is so slip speed will decrease and the torque will decrease. Torque will decrease and the power is equal to constant and the flux is a variable means as frequency increases, flux will decrease. So therefore we can say the slip speed increases means wrong. It should actually decrease because ns minus nr it is decreasing. As I have already told you, torque will increase means it is wrong. Torque is actually decreasing. As I have already told you, stator current increases means it is also wrong. So finally, power developed remains constant is the correct solution of this question. So now we are going to solve the 90th question. See the question here. It is the match the following type of question. In the group 1, they are given the quantity, and in the group 2, they are given the unit. So we need to match them. So illumination, the unit of the illumination is, which is meter candle, whereas the unit of the luminous intensity is lumen per steradian, whereas the unit of the lamp efficiency is, which is lumen per watt, whereas the unit of the solid angle is, which is steradian. So option A is the correct solution of this question, but let me discuss something more about this one. So the unit of the illumination is either lux or lumen per meter square, or foot candle, or you can even call this as the meter candle also. So we can say these are the different types of units of the meter candle, foot candle or meter candle. So these are the different units of the illumination. Different units of the illumination. So therefore, the different units of the illumination are lux or lumen per meter square or foot candle or meter candle. So what is the definition of illumination means? It is defined as the luminous flux which is received by the surface per unit area. Means how much amount of luminous flux which is received by the surface per unit area. Means the amount of luminous flux received per unit area on the surface is called as the illumination. So in 0 liter, lux or lumen per meter square or foot candle or meter candle. Now the luminous intensity, the unit of the luminous intensity is candela or lumen per steradian. So these are the different units of the luminous intensity, which is candela or lumen per steradian. The definition of the luminous intensity is the quantity of visible light that is emitted in a unit time per unit solid angle. The quantity of visible light that is emitted in a unit time per unit solid angle is called as the luminous intensity. Whereas the luminous flux, the unit of the luminous flux is always lumens. The definition of the luminous flux is the amount of light energy which is radiated from a source. The amount of light energy which is radiated from a source in all directions per second is called as the luminous flux. The amount of light energy which is radiated from a source in all directions per second is called as the luminous flux. Then lamp efficiency. The lamp efficiency unit is lumen per watt. Means for 1 watt of energy consumption, how much amount of lumens are delivered by the lamp is called as the lamp efficiency. Or simply we can say the visible radiations which are emitted by it in the lumens per watt, or the for 1 watt of consumption of energy, our how much amount of lumens are delivered, it is called as a lamp efficiency. Whereas the unit of the solid angle is steradian and the unit of the plane angle is radian. So these are the quantities and the corresponding units. So option A is the correct solution of this question. So now we are going to solve the 99th question. See the question here. In distribution networks, which of the following circuit breakers are more suitable or more preferred? So in distribution network means the voltage rating is from 11 kV to 33 kV. So in these voltage ratings, which of the circuit breakers are more preferred or more suitable? Out of these four options, option B, which is vacuum circuit breakers, is the correct solution of this question, because the vacuum circuit breakers requires least maintenance when compared to any other circuit breaker for the distribution networks, means the voltage rating is lying from 11 kV to 33 kV. So option B is the correct solution of this question. So let's discuss something more about this one. So now let me give you the different types of rated voltage and the circuit breakers which are available for this corresponding rated voltage, and out of the circuit breakers available, which is most preferred, circuit breaker also we are going to discuss. So for a voltage rating of less than 1 kV, the available circuit breakers are only air brake circuit breaker. So by default, as there is only one, so definitely it is always preferred, which is air brake circuit breaker. Whereas from 11 kV to 33 kV, this is nothing but distribution voltages in the India is from 11 kV to 33 kV. So therefore, for this rating of voltages, the available circuit breakers are vacuum circuit breaker, SF6 circuit breaker, minimum oil circuit breaker. Out of these three, the most preferred circuit breaker for this corresponding rating is vacuum circuit breaker. Whereas for 132 kV to 220 kV, for this rating of voltages, the available circuit breakers are SF6 circuit breaker, air blast circuit breaker, and minimum oil circuit breaker. So out of these three, the most preferred circuit breaker is the SF6 circuit breaker. Similarly, from 400 kV to 760 kV voltages, available circuit breakers with these ratings are only SF6 circuit breaker and the air blast circuit breaker. Out of these two, the preferred is the SF6 circuit breaker. So if you see clearly, for a voltage rating above 132 kV, it is also SF6, it is also SF6. So therefore, for a voltage rating of above 132 kV, the default circuit breaker which is preferred is SF6 circuit breaker. Whereas for the distribution voltages or distribution network voltages, the preferred circuit breaker is the vacuum circuit breaker. Whereas for the very low voltage ratings, the preferred circuit breaker is the air brake circuit breaker. So therefore I can say for very low voltage ratings, the preferred circuit breaker is air brake circuit breaker. Whereas for the distribution voltages, for distribution network voltages from 11 kV to 33 kV, the preferred circuit breaker is the vacuum circuit breaker. Whereas for a voltage rating of above 132 kV, by default we are going to prefer the SF6 circuit breaker only. So you can see here also SF6, here also SF6. So for a voltage rating of above 132 kV, the default circuit breaker is always SF6. So let me write here, as I have already told you, for a voltage rating lying from 11 kV to 33 kV, this is called as a distribution network voltages. Here we are going to prefer the vacuum circuit breaker is always preferred, because the maintenance is very least when compared to any other circuit breaker for this corresponding voltage ranges. Whereas for a voltage rating of above 102 kV, always we are going to prefer the SF6 circuit breaker only, as I already told you. So these are the two important things always you have to keep in your mind. So finally I can say, for a low voltage ratings, always air brake circuit breaker is preferred. Whereas for distribution voltages, for distribution network voltages, vacuum circuit breaker is always preferred. Whereas for a voltage rating of above 102 kV, always SF6 circuit breaker is always preferred. For SF6 gas, the dielectric strength is always greater than the air. So SF6 gas has a dielectric strength is always greater than the air. It is nearly equal to 2 times of the air. The dielectric strength of the SF6 gas is nearly 2 times the dielectric strength of the air. So these things always you have to keep in your mind. So option B, which is for distribution network voltages, the most preferred circuit breaker is always vacuum circuit breaker is the correct solution of this question. So now we are going to discuss the 100th question. See the question here. Identify the correct statement of the following. So they are given 4 statements and they are asking which is the correct statement we need to figure out. So statement A, which is Butchow's relay is not a gas operated relay. No, it is wrong. Basically, Butchow's relay is a gas activated relay and it is going to protect the transformer from all internal faults. It is a gas activated relay, but this statement is wrong. Second statement, IDMT relays are used to protect the transformer against the external short circuits and overloads. No, this IDMT relay is basically used to protect the transformer from only external short circuit faults only, but not from overloads. Overloads means it is thermal overload relay is basically used to protect the transformer from overloads. But IDMT means only external short circuits only, but not overloads. So this is also wrong. And the third one is differential production is used for generators below 10 MVA. No, it is above 10 MVA. Differential production is also called as the burst price production. So with this, we are going to protect the stator windings of the synchronous machine or alternator of generators. So this differential production of the burst price production is used for the alternators for rating of above 10 MVA only. So therefore, this is also wrong. The final is for transformers rated more than 1 MVA, the percentage differential production is used against the short circuits. If these 3 are wrong, means by default this is correct. So option D is the correct statement. But let me discuss something more about this one. So now we'll discuss something important facts or points. So I've already told you Butchow's relay is basically a gas activated relay and it is going to protect the transformer from all internal faults. See, the Butchow's relay is basically gas activated relay, means it is going to basically function based on the gas. It is used only for oil immersed transformer. Suppose if the transformer is going to get heated, then because of this heat, the oil is going to get heated. So because of this, gas bubbles are going to get liberated. This gas bubbles is going to sensed by the Butchow's relay and it is going to trip the incoming layers of the transformer and it is going to protect the transformer from all internal faults. It can even anticipate the future fault also. So now, IDMT relay, as I have already told you, these are used to protect the transformer from the external short circuit faults only. IDMT relay are basically used in the transformer in order to protect the transformer from only external short circuit faults only. Whereas for a thermal overload relay, it is used in order to protect the transformer from only overloads. So we can say IDMT relay is used in the transformer in order to protect the transformer from external short circuit faults. Whereas thermal overload relay is used in the transformer in order to protect the transformer from overloads. Whereas I have already told you, for a generator having a rating above 10 MVA, by default we are going to use the differential protection scheme or burst price deflection scheme. With the help of this one, we are going to protect the stator windings of the alternator from incoming currents. So therefore, we are going to protect the stator windings from these negative sequence components of currents. So here we are going to use the differential production is used only for ratings of alternator above 10 MVA only. For below this one, we are not going to use this one. So whereas for, as I have already told you, for a transformers which are rating more than 1 MVA, then we are going to use the percentage differential production. So these are the facts or important points. So therefore we can say only option D is the correct solution of this question.